From this video, we'll understand how a motor or a generator works. And actually, not or, and. So for that, we need to understand that a moving charge in a magnetic field will experience a force. Again, an electrical charge particle moving in a magnetic field experiences a force, while there is no such force for a stationary charge. So we are going to make use of this, three-dimensional space, wherein three-dimensional diagram, wherein we have, say, a magnetic field. We have a particle moving, say, at an angle of theta. Okay, and this is your, let me finish the diagram actually. So this would be, say I'm taking this as B, and this is your movement of the charge. So to this plane, to the XY plane, what is the perpendicular line? Z axis. And that will be the direction of the force. Again, this is observed in nature, and we are just learning about it. So that will be the direction of force. So this is basically to do with S cross product. And so basically we are looking at this length of V that will count. Anyways, that's not the point over here now. So we have a charge over here that's moving with a velocity of V and exposed to a magnetic field of B. It will experience a force which is perpendicular to this plane with a force of F. So this is the entire funda. So mathematically, let's consider charge Q, coulomb of charge. So this is Q coulomb of charge. Moving with the velocity of V. So here the drift velocity is represented Vd. We'll talk about drift velocity. For now, we just consider that the current velocity of the current per se. Making an angle of theta with B. So angle of theta, that is angle between B and Vd. That's the language. I'm using capital letter V. The force on the charge is proportional to. This force is proportional to magnitude of the field. It makes sense. The charge itself, that also makes sense. The component of the drift velocity Vd, that is perpendicular to the direction of B. So basically, this matters. What is this? This is the perpendicular component of V. So basically V, if you guys do the math, this is sine of theta. Okay, just do the math. You take up a line, this is V and this is theta, drop a perpendicular, this is 90 degree. So this is the opposite side. And this is hypotenuse. Same thing, I've drawn it over here. So this has to be V sine theta. So the component of the drift velocity Vd that is perpendicular to the direction of B is so. Right? And now, as per all of this, what do we have? We have one is B, the force is proportional to B, Q, and V sine of theta. So when we remove the proportionality symbol, we get a proportionality constant K, Q, V sine theta. So the K is, the entire unit is defined in such a way that K will be equal to 1. The unit of field is defined in such a way that K is equal to 1. So let me put it this way. Our entire definition of everything is human made. 1 kg, the idea of 1 kg is human made. The idea of 1 meter length is human made. Now, when it comes to force, it's dependent on your acceleration, so on and so forth. That in turn is dependent on meters and second. Even second is human made. So when we have all of this to be human made, we have, as of today, the math turns out that K should be equal to 1. The force definition B, Q, V, sine theta, all of this will turn out that if K is 1, LHS will be equal to RHS. So K doesn't have to be anything else. Okay, guys. So if you understand that, then this statement will make sense. If not, it's like you're just by hearting. That should not be the case. You just have to understand the human psychology over here. We have defined everything. We're observing the nature and putting a language to it, and that is maths converted to physics. A fancy maths is physics, nothing else. A fancy physics is chemistry. A fancy chemistry is biology. Right? So everything has to do with understanding nature. So this will be equal to BQ V sine theta. Now, this is not the ultimate version of the formula. We know that, right, as the force is perpendicular to the plane of B and V. What does this imply? Force is a cross product of V and B. And therefore, F is equal to Q V B. So how do you decide V is first or B is first? Again, your right hand rule, open your palm, open your hand. The palm, if it swipes, in this case from V to B, right? V to B, the thumb will be pointing up. That should be the direction of force. So in that convention, we have to measure the angle from V to B. Okay, yes, it's again all human made. So the expression. Does it make sense? Now, special cases. Here the charge is at rest, the very first one. So here V will be equal to 0. So the force will be equal to 0, right? The charge is moving parallel or anti-parallel to B. So here theta will be equal to what? Either 0 degree or 180 degree. Okay. And therefore F will be 0 as sine of 0 is 0. Okay, we have one more case. The charge is moving perpendicular to B. So this is the case of maximum. So theta is equal to 90 degree or 120 degree. So we have F is equal to QVP. So this is the case of maximum force for this setup, for this charge, for this velocity, and for this magnetic strength. Right? So very simple. How we got to observe that a current carrying conductor can create a magnetic field. The magnetic field also can alter the movement of a charge. It can exert a force. And that's what we're trying to learn. So we got to see that it depends on how strong the magnetic field is. It depends on what is the charge strength, basically the value of charge. And we got to see how fast it was moving. We got to see that all of this mattered and at what angle also. And we made up a formula. We came up with a formula, and this formula turns out to be this. That's it. Nothing else. That's all we're trying to learn in this video. Okay, so this is a fact, and we just have to know this. Okay, so now it's time for you guys to draw everything. So that's your right hand. This is to do with the sine component. Okay, so yeah, now you can draw.